Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important question, that is from magnetostatics. So, what is that? This area is boundary conditions of the magnetostatics. So, we know that four boundary conditions we have for magnetostatics. So, what are those boundary conditions? First we have to see, the latter you have to do the question for this. In GATE 2013, this question asked once, you have to see, at a surface current, which one of the magnetostatic boundary conditions is not correct, they are asking. Before going into read these questions, first you have to learn about what are the magnetostatic boundary conditions. Suppose you are able to take maybe this is the surface charge you have to take, this one is the surface charge you have to take. So, there is a surface current is passing through here. Here you have to construct the Gaussian pillbox, you have to construct above the surface you able to take and below the surface you have to consider. So, based on this surface current density, there is a four magnetostatic boundary conditions are there. So, first boundary condition 1 you have to take. So, what is the first boundary condition? The normal component of magnetic field at the boundary is equal to continuous. B12 is equal to B21. What is that? The normal component of magnetic field, at the boundary is continuous. The normal component of magnetic field is continuous at boundary, at the surface, at the boundary or at the boundary surface. Clear? Right. This is the first one. The second one, how we have to get, already you know that. So, del dot B is equal to 0. Based on that, we have to derive this one. Integral B ds is equal to 0. From that, we have to take it as a, the normal component of above the surface is equal to the normal component of below the surface. The second one is the parallel component of, means the tangential component, we need to write it is the tangential component of B12 minus B21 of t is equal to, what we have to write it is mu naught into k cross n cap. This is the tangential component of the magnetic field. The tangential component of the magnetic field is discontinuous. The tangential component of magnetic field is discontinuous at the boundary, at the boundary, at the surface or at the boundary, you have to write it. So, this is the second one. Now, you have to see the third one. So, what is the third one you have to take? Option A you have to write, and third one 2 is there. The normal component of magnetic vector potential, the normal component of magnetic vector potential is continuous. So, what is this? The normal component of what? The normal component of A is continuous. The normal component of A is continuous. The normal component of A is equal to continuous. The B1 you have to see, what is the B? The tangential component of A, here 2 also continuous. The normal component of A from del dot A is equal to 0. From this we have to write it is, from here integral A dot dl is equal to phi b. From this we need to write this one. So, therefore, the tangential component of what? The tangential component of A is continuous. The tangential component of A is continuous. There is a fourth boundary condition is there. So what is that fourth boundary condition? You have to see the normal derivative of A above is divided by dou n minus dou A below is divided by dou n, which is equal to minus mu naught into k. This is discontinuous. Which one you have to write it is? This is discontinuous at the surface. This dou by dou n is normal derivative of the magnetic vector potential. So these are the four boundary conditions we have. The first one is the normal component of B is continuous, the tangential component of B is discontinuous, the normal component of A is continuous, the tangential component of A is continuous, the normal derivative of A is discontinuous. So these are the four boundary conditions. So what are these boundary conditions? Magnetostatic boundary condition. These four boundary conditions are magnetostatic boundary conditions. These boundary conditions we call it as a magnetostatic boundary condition. From this we have to solve this question. How we have to solve? Once you have to see option A surface current. Which one of the magnetostatic boundary condition is not correct? They are asking. Which one of the boundary condition is not correct for a magnetostatic? The first one you have to see. The normal component of the magnetic field is continuous. The normal component of the magnetic field is equal to B12 is equal to B2n. So this option is the correct option. The normal component of the magnetic field is continuous. The second option you have to see, the normal component of the magnetic vector potential A1n is equal to A2n. This is also correct because this one you able to get based on the del dot B is equal to 0. We have to get this one. So this one you have to get it based on del dot A is equal to 0. You have to get this one. So the normal component of magnetic vector potential is continuous. Option B also correct. Now you have to see the tangential component of magnetic vector potential. The tangential component of A1t is equal to A2t. This is also correct. How we have to get it? Integral A dot dl is equal to phi b. So your phi b, so based on the magnetic flux we have to write it is the tangential component of magnetic vector potential is continuous. Option C also correct. Now you have to see obviously not correct one. These three are correct. A correct, B correct, C correct. Not correct one is D only. So that D you have to see. The tangential component of magnetic vector potential is not continuous. So what is that? The tangential component of magnetic vector potential is continuous, but they are giving the condition is not continuous they are giving. So that's why option D is wrong option. Which option it is? Option D is wrong option. Like this we have to do in our competitive examination. Clear? So we started the CSIR and GATE Physics online coaching center. We have one app, that is Quantum Online Academy app is there. You download my app. After downloading my app, you able to see the courses. The courses will appear like this. CSIR and GATE Physics course will appear like this. Not only this, so JL Physics and DL Physics content also available. So first you have to take this course. This course is sufficient for all round. So because entire the portion, whether it may be DL portion or JL portion, entire portion is available in this. So that's why this course is more sufficient for you if you have to take this course. So not only that, so individual papers also I uploaded. So first if you want to take only mathematical methods of physics, you have to take only mathematical methods of physics. So only mathematical methods of physics, now entire paper is available. So core and advanced CSIR syllabus is finished. So entire thing is available. Now you have to take the classical mechanics. This is the second one. You have to take the classical mechanics. This classical mechanics paper also completed with core and advanced of the CSIR syllabus. The full syllabus we covered once you have to see in this content. Now electromagnetic theory we started. This course is live plus recorded classes are going on. Live plus recorded classes are going on every day in between 6 a.m. to 8 a.m. Every day in between 6 a.m. to 8 a.m. there is a live class is there. Once you have to join in this course, you able to take the, you able to listen the live class also. So that is the class. After that class 1 year validity is there, the recorded one also. Please inform to your friends who are interested to crack the CSIR exam or who are interested to get the JL or DL competition purpose. So to learn the subject at a time you are unable to learn it. So that's why you have to take this course. This course is very much useful to you. So please share and subscribe our YouTube channel. Like these videos, I will upload in our YouTube channel. Thank you so much for your encouragement. Thank you.